All right, welcome back, and I want to go ahead and move into a new topic for today. We're going to look at probably our best quantitative graph, and that would be histograms. And histograms it's similar in some ways to dot plots and to stem plots in that they can show SOCs, shape, spread, odd characteristics and center. Don't have that in the right order, but I do have them all accounted for. But it's not going to be limited to just small data sets of discrete quantitative data. This is going to be a professional type of graph. It's what you would generate with a computer, or perhaps Excel can do it, some other programs. Actually, Google Sheets can do it. But we're going to do these by hand to get a sense for how they're constructed, and we're going to see that they can accommodate any kind of data and any amount of data, even if it's a large number. So getting started, here is a histogram. There it is. This is scores on a DRP test, which is I believe, some kind of achievement test. And the scaling here is a little funny. I believe this is going to be starting at 10, 15, 20, 25, 30, like that. So you don't have to start at 0 here. You don't need any dead space. This is a frequency histogram. It's going by counts. It's not percentages. If it were, it would be relative frequency, and that's going up to, I don't know, it looks like 14. And you can tell that these are made up of bars, but it's not a bar graph, because in a bar graph, each one of the bars would be separate and distinct, because you would be dealing with a quantity within a certain category, and there would be more than one of them. Here, for a histogram, we're only dealing with one category. These are just scores on a particular test, and they just range from, I guess, down to 10 up to around 60. So 60 minus 10 would be our range, which would be 50. We would need our original data to get the median, and I don't see anything too odd. I don't see any outliers or gaps or clusters or anything like that. But what I am seeing is something that, if I can get my pen over to work, is skewed to the left. So we can comment on SOCs. We've got labels, we've got titles, we've got scales. Everything is as it should be. It's very readable. And yeah. So those bars are we can really use two words. I like to use the term classes. Each bar is a class. But you may understand them a little bit better if you call them bins, because they're like a trash bin or any kind of a bin that you might store, I don't know, nuts and bolts or anything. And you throw things in the bin and they accumulate either percent of the total, or they are just some part of the total, like a count. So we can have a frequency or relative frequency. That would be your height. Okay, how tall a certain class is how many data observations occurred within that particular class or bin. Number of bins are determined by your sample size. If your sample size is small, you don't need too many, but if your sample size is big, then you need to accommodate all that data, and you do it by including more bins. All right, now a lot of what I'm going to tell you now is not really applicable to you directly, because you really aren't applying it. You're just getting some sort of random information, but just absorb it, jot it down. In order to determine how many bins we need, if n is less than or equal to 8, then we need 3 bins. If n is between 9 and 16 inclusive, we need 4. If n is between 17 and 32 inclusive, we need 5. And if n is between 33 data values and 64 data values inclusive, we need 6. The next one would top out at what? 128, because look, these are all 2 to a power. 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, then 2 to the 7th would be 128. Now, typically we don't really encounter too many instances where we need to go beyond 6 bins. We don't have huge data sets, but I think there are a couple where we do need 7. But if you have trouble remembering, just remember the upper value here would be 2 to a power. So 2 to the third, that's 3 bins, right? 2 to the fourth, that's 4 bins. 2 to the fifth, that's 5 bins. 2 to the sixth, that's 6 bins, and so on. So that'll help you to remember. All right, a couple more things about histograms. To figure out how wide to make these things, these are your class limits. They're going to be divisions in your x-axis. Remember we had those up in the histogram in the previous slide. We take our biggest value in the data set, we subtract the smallest, and we divide by the number of classes that we got from using these guidelines here. Now this is key here. Anything in red with asterisks is important. Always bump up to the next integer. So if this fraction becomes 6.2, then that bumps up to 7. If it's 6.8, that bumps up to 7. If it's exactly 7, it stays 7. But if it's 7.1, it goes to 8. This is important because I'm going to teach you a way to do these that works. It's very elegant. It's totally foolproof unless you screw it up. Like you forget to bump up to the next integer like that, then that's a problem. You'll end up with data at the end of what you're doing with nowhere to go, and that's not good. All right, so anything that's beyond an integer, bump it up to the next one. All right, if we're doing relative frequency, that's just the amount within your bin, that class frequency or bin frequency, divided by the total number of data points. I'm going to show you how to do that. It's a very quick way. We can do it like a spreadsheet. And really, these are the only 2 things that you need. In case this should come up in your reading somewhere, or if you should see this, if you want to take one of those bars and put a dot halfway from one end to the other, going left to right on the top, that's a bin midpoint, and it's good for drawing things like certain kinds of line graphs. We aren't actually not doing them, so we're not going to use this, but if you need the midpoint, it's like the midpoint formula. So it's the bin upper limit, you add the lower limit and divide by 2. All right, so those top 2. This is the homework. It's the same worksheet as last night, except the last 3 are going to be to build histograms. All right, so today's homework code is this number here. You can go ahead and pause this and enter it if you haven't done so already. And hang on. Okay, we're back, and I'm going to put away this particular PowerPoint. It was pretty short. And I'm going to go ahead and open up a note sheet. This is a note sheet that should be in your packet. And it's got all this data here. There's 60 values because we're measuring the commuting distance, the traveling distance for 60 workers in downtown Dallas. And these are in miles. So we need to fill this in because what we're going to do is create a frequency table and then, or distribution. And then off of that, we're going to go ahead and just draw out the histogram. So if I remember, well, it's no need to remember here. Here is 60 workers. So we can say that N equals 60. All right, so if you remember back from how to figure out how many bins or classes, that's between 33 and 64. 64 is 2 to the 6th. So we need 6 classes or bins. So number of classes will be 6. Now we need to know the class limits. So we need our maximum value, our minimum value, and then we're going to divide by 6. So I'm just going to start a fraction here divided by 6. Don't forget to bump up, right? So I'm just going to asterisk that twice so we don't forget it. Now you can look in here and try to find the minimum value and the maximum value, but I'm just going to go ahead and use the calculator for this. So I'm going to show you 3 different ways, starting out with the n-spire. All right, so this data is already in. You get in here by choosing a spreadsheet, and I'm just going to go to the current one, and go ahead and label this. This is miles. This will help us in a lot of cases to have a label on here, and then you type in all 60 of those values. So I'm going to give you a second to do that. You might want to go ahead and pause. All right, assuming that you went ahead and did this, we need to get this in order, because if we can, the first cell is going to be our X min, and then we can look at the 60th one and find our X max, and we won't have to go searching. So I'm going to go ahead and select this entire column. See, it's all selected. Now, I had a lot of problems with this in my first go with this video, so keep your fingers crossed. It's going to be under Menu and Actions, and then down to Sort. Hey, look, it worked. So we've got the right column, and we're going to sort it ascending from least to greatest, and we're just going to hit OK. All right, so the minimum is going to be 1, and we're just going to go down, and this can go down relatively fast, so we may overshoot, and we'll have to come back to it. But you can see on the side that those are the, all right, so there's the 60th one, that's 47. So 47 minus 1 is your numerator. All right, so I'm going to show it to you in the 84. And let me go ahead and load this file. So data for histogram. All right, and here it is. Basically what you do is you do stat and edit, and you don't change the name of this. You actually can go up here and change it, but it's not going to be part of a graph or anything. So just leave it at L1 and type those in. And if you've got this kind of calculator, then pause the video. So now, assuming that you got this in, and you can track how many numbers you're putting in by what's in these parentheses, you should have ended up with 60. All right, so to get this sorted, go to Stat, and remember choice 2 is Sort Ascending, and that's your L1 list. It may default to that, but I'm just going to put it in. Hit enter, it's done. Stat edit, and there's your low one. Now you can get to the 60th one pretty quickly by just arrowing up a couple of times, and see your 60th one is 47. So 47 minus 1. Now the last thing I want to show you is if you just don't have a calculator at all, and that would be in a Google Sheet. Now look, I put this in a lot of times because Google Sheets have a tendency to save things and you can't undo them. So I went ahead and just put in this data, and I actually copied it to other ones in case I need it. And what you do here is just go ahead and choose that column and go to Data. And you don't want this top one, because if you sort this, it sorts the whole sheet, right? You just want to sort that column, so sort range by column, and A to Z is really least to greatest. So choose that, all sorted. And you can scroll down and see what your last one is. See, it's 47, and your top one is 1. So I'm just going to undo that and get out. All right, so I think we're all convinced of the values that we got. So this numerator here, let me get my pen back, there it is. This will be 47 minus 1, and this fraction will come to 7.7 or 8. All right, that's the bump up. So we did not forget to bump up. So what this is telling us is the width of those bins or classes will have to contain 7 distinct types of data. You'll see when I go ahead and develop this. So to get your class limits and to figure out the width and everything, the lowest value that we had for data was 1. It could be 0, okay? And now we need to have 7 more to make 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. That's from 1 to 8. So I'm just going to undo that. So it's your first value, and then add 7 more. So now we need a data value that would be 9, because we already have 1 through 8. And then 7 more would be 9 through 16. And then we need 17 plus 7 more would be 24. Then go up 1, 25 plus 7 more is 32. You can count those on your fingers. 25, 26, 27, 28, 29, 30, 31, 32. That's 8 values. All right, then 33 plus 7 will take you to 40. And then 41 plus 7 more would be 48. That's 1, 2, 3, 4, 5, 6 classes. Our biggest value is 48. We've got a bin for everything. All right, now this is a start, and it'll tell us what numbers go into this first class, what numbers go into the second class, what go into the third. But they don't touch each other, right? You've got a space of 1 unit between 8 and 9, 16, 17, 24 to 25. Those are blank. These need to be touching. So what we're going to do to fix that is take half off of the low end and add it on to the top end. So 1 minus 0.5 is 0.5. And then we'll add 0.5 onto that, and we'll get 0.85. And then this, if we take half off of 9, we're going to get 8.5. See how those two things touch? Up to 16.5. And you just keep going like that. 16.5 to 24.5. And then 24.5 up to 32.5. 32.5 up to 40.5. And then finally 40.5 up to 48.5. Okay, this is how you're going to label your x-axis. Now that x-axis does not have to start at 0. This first number could be negative, and you just put them in the first quadrant. This is not like Algebra 1. You don't want a class in 2 different quadrants. Everything's in the first quadrant. So you're going to label your x-axis like this, and when you see the finished product, you'll see how it's labeled. Now we need to know how many data values go in this range of numbers and how many go in this range of numbers. So let me show you how that works. It's very simple. Just go back to your calculator, and let's go back here. And typically I kind of start outside of this and just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 14. So those numbers 1 through 8, we had 14 of them. And you can do that with the other things that we had, the 84 and the spreadsheet. So getting back here, we had 14. Right, so if we're going to make a frequency histogram, this first bin will be 14 units high. So if you do it for the next one, it's 21, and then 11, and then 6, and then 4, and then 4. And this should add up to 60 so that everything is accounted. This is not necessary for the frequency table, but I'm just making sure you know that we're not leaving anything out. If you get these numbers wrong and you're off, like this is a 10 and this is a 7, that is not a major error. It really doesn't make that big a difference. It's not going to be perfect, but this kind of thing is not necessarily perfect. Yeah. So now this is enough to actually build a frequency histogram. But if we want a relative frequency histogram to complete this frequency distribution, at least for today, because there's really 2 more columns after this, we need to express these values, these counts, as percentages shown as decimals. So this is 14 divided by 60, and then 21 divided by 60, and then 11 divided by 60. Now this is pretty tedious. This is not kind of the way we really want to do things, but this is essentially what you're going to be doing, and you don't need to report this. I'm just showing you this because it's notes. So what I would do would be to go back into your calculator, and let's go ahead and just tell this that this is X. So I'm going to label this X, and that's just going to be the 14. So 14, and then 21, and then 11, then 6, then 4, then 4. And all I'm doing now is putting those in here so that I can convert these to a proportion. So I'm going to scoot over here and call this Y. Always good to give these a name. Then I'm going to go down into this field right here, and this is going to be where a formula goes, like a spreadsheet. So let's go ahead and say that this is going to equal, here's your equals key, it's going to equal your X column values divided by 60. And I'm going to do 60.0 so that I don't get fractions. Now hit enter, and these are going to be both variable references. Well, there you go. So that's 0.23, 0.35, 0.18, 0.1, 0.07, and then another 0.07. And it should add up to 1.0. If you're off by a little bit, that's fine. So this was 0.23, this was 0.35, and then we have 0.18, and what was it, 0.10, right? And then 0.07, and then 0.07. So if we want to go ahead, and by the way, this should add up pretty close to 1. If you're off by a tenth, that's just going to be a rounding issue. Don't worry about it. And so we can build either a frequency histogram or a relative frequency histogram. Now, just so that I can show you in the other calculator, hopefully I get this right. So let me turn this on, and you can come over here and highlight, and that means you're about to put a formula here. So go ahead and do L1 divided by 60. Oh, wait. No. Let me clear that out. Let me delete that. Hang on. My bad. I actually didn't put the frequencies in here. So let's go down in here and put your 14 and your 21 and your 11, 6, 4, 4. All right, now let's scoot over to this one after we hit enter. So let's scoot over here and highlight it. Now we can go ahead and do this. This is actually going to be L2. So second and then 2 will give you L2 divided by 60. And whoops, I get the feeling I put in the wrong formula. So let's clear that out. And let me go ahead and replace that. I think I hit times. So L2 divided by 60. This is live TV. Okay, that's what we want. All right, so remember, garbage in, garbage out. So we're ready to go on to the histograms. This is completed for notes. And so let me go ahead and open up the histograms. This is the same thing I showed you before. And let me shrink this down so it shows. All right, title, one-way commuting distances for 60 workers in Dallas. I did frequency first, right? And I didn't go all the way to the top here. I just needed this to be a good histogram that was not too stretched or too compressed. So I went ahead and just did every other one by twos. It's just like 1, 2, 3, 4, like so. And it got me up to my most that I have in any expected count is, or frequency count rather, is 21. So I just kind of went up to 26, just kind of randomly. And now here are those values for your class boundaries. And I started at 0.5 to 8.5. And you can, I went just 3 values, like just 3 squares. You could do 4 if you want, whatever. And then 16.5, 24.5, 32.5, 40.5, and 48.5. I labeled it frequency. It looks good. That's what I'm expecting you to do. And here it is, relative frequency of one-way commuting distances for 60 workers in Dallas. And all I did was replace the counts with the proportions. And it's the exact same thing. So if we describe this, this is going to be skewed to the right. And there are no unusual values. This is going to range from 1 to 41, which is 40 for the range. And we'll get a better sense for how to do spread without resorting to the range later. And then you can count up the median. That would be the average of your 30th and 31st value, and that would give you your median. So you can do your all of your SOX values pretty quickly and pretty easily. So there it is. I just shaded it in so you could tell the difference between the histogram and the clear spot. You can do cross-hatching or slanted lines or anything you want, just so that you can tell, you can see it, okay? So I think we are done. And I'm just going to go ahead and stop, and you can start your homework or do whatever.